Good morning, children. See, in the last period we studied about the projection vector of B on A or A on B, like that. We solved one or two problems. We'll do some more problems, but before that we'll do the theorems first. There are about 5 theorems which are very important for 7 marks essay type questions. So show that by vector method. You already know that in any triangle the altitudes are concurrent, perpendicular bisectors are concurrent. What are concurrent lines? They are the lines which intersect at the same point. They have one point in common. So here ABC is the triangle, and then you draw one altitude. Altitude is the height. This is the height. And BAD I'll take. AD is one altitude, and then E is another altitude. You must show that the altitude through C is also passing through the same point. So this point is the point of concurrence. We must show that all the 3 altitudes intersect at the same point. So the procedure to prove in vectors is like this. First we take the triangle. First we'll discuss these two together and then we'll write the notes. So ABC is the triangle. ABC is the triangle. Draw one altitude through A and through B. Any 2 altitudes you draw. Suppose that they intersect at some point, and we'll take that point as O, and O be the origin. So let the altitudes AD and BE intersect at O and O be the origin. So you have ABC triangle, and then you are drawing 2 altitudes. They are intersecting at some point, and we are taking that point itself as the origin and defining the vertices OA as A, OB as B, and then OC as C. So we'll define the vertices with respect to that point. Now I must show that the altitude through C, that means CO, is also perpendicular to AB. Then all the 3 altitudes intersect at the same point and they are concurrent. So like that we prove. So now what we do is, AD is one altitude, no? So that means AO is, or OA is perpendicular to BC. OA is perpendicular to BC. OA is A. What is BC? Actually we have OA is equal to A, OB is equal to B, and then OC is equal to C. So what is BC? BC is OC minus OB. So A is perpendicular to BC, that is C minus B. Because they are perpendicular, their dot product is 0. So A dot C minus B is equal to 0. So it is distributive. A dot C minus A dot B is equal to 0. So that means A dot C is equal to A dot B. So we have one equation like this. So from OA perpendicular to BC, we got this equation. Now we'll take BE, or OB is perpendicular to. Next, OB is perpendicular to, OB extended is perpendicular to AC. So their dot product is 0. OB dot AC is equal to 0. In the same way, if you do, it is B dot of C minus A is equal to 0. Or B dot C is equal to B dot A. So like this you get. So from these 2 equations, what you do is, these are the 2 equations according to our assumptions. Now B dot A is same as A dot B, no? So A dot C should be equal to B dot C. So from these 2 equations you get A dot C is equal to B dot C. That means A dot C minus B dot C is equal to 0. So it is A minus B dot C is equal to 0. A minus B is nothing but BA. BA vector is dot C. C means OC. So BA dot OC is 0. So that means BA is perpendicular to OC. So BA is perpendicular to OC. So that means OC is also passing through O, and OC extended line will meet here. So OC is also the altitude passing through O. So they are all concurrent. So like this we prove using vectors. By vector method, we prove that they are concurrent like this. Now next one is, show that the perpendicular bisectors of the sides of a triangle are concurrent. So here what we do, in the same manner, we'll take the triangle ABC and then bisector of the side means for BC side, we'll take the midpoint, we'll draw a perpendicular. So this is the perpendicular bisector of BC. Now you take another side, either this side or this side. Suppose I take this side, this is the midpoint, we'll draw a perpendicular, so that will intersect at some point and that point will take as O. So let the perpendicular bisectors of the sides BC and AC intersect at O and O be the origin. So let these perpendicular bisectors, two perpendicular bisectors intersect at O and O be the origin. Now you must show that the midpoint you take, that vector and O, that point and O, that vector is also passing through O. That is what you have to prove. So what we do is, we'll take this O as origin. So in the same way, OA will take as A, OB is equal to B, OC is equal to C, OC is equal to C, and then suppose that this is D and this is E and this is F. D is nothing but the midpoint of BC. D is the midpoint of BC. B point is B, C point is C. So what is the position vector of D? That is OD. D point or OD is midpoint formula, B plus C by 2. It is B plus C by 2. So now OD is perpendicular to BC. OD is perpendicular to BC. So that means OD dot BC is equal to 0. OD is B plus C by 2. B plus C by 2. What is BC? BC vector is OC minus OB. OC minus OB. So that means C minus B. So we'll write C minus B is equal to 0. Dot of this. So now it is B plus C dot C minus B or C plus B dot C plus C minus B. So it is C square minus B square by 2 is equal to 0. Anyhow that 2 will get 2 into 0 becomes 0. So C square minus B square is 0. So C square is equal to B square. C square is equal to B square. So now OD is perpendicular to BC. From this we got C square is equal to B square. Now again you take this AC. AC is perpendicular to OE. OE. So AC dot OE is equal to 0. AC dot OE is equal to 0. So AC means C minus A dot OE. E is the midpoint of AC. So it becomes A plus C by 2, that is equal to 0. So C minus A dot C plus A by 2 is 0. So you'll get C square minus A square is equal to 0 or C square is equal to A square. So from these two equations you will get C square is equal to A square, C square is equal to B square, implies that A square is equal to B square. So A square is equal to B square. Now, yes, now you can write A square is equal to B square. So you can write A square minus B square is equal to 0 or A plus B dot A minus B is equal to 0. A plus B dot A minus B is equal to 0. Or you can write A plus B by 2 dot A minus B is equal to 0. We are trying to get it in this form so that you can write A plus B by 2 is nothing but the position vector of F, OF. So that means OF dot AB. A minus B means BA vector. BA is equal to 0. So OF is perpendicular to BA. F is the midpoint. F is the midpoint of A plus B by 2. So that means the perpendicular bisector of AB also passes through O. So all the three are concurrent at O. So like this we prove this property by vector method. Now we'll write everything in detail again. Now one more theorem is there. Prove by vector method, prove that the angle in a semicircle is a right angle. Another theorem is there. So by vector method, prove that the angle in a semicircle. So this is your semicircle. Take the midpoint. This is the center. Show that the angle at any point, you take any point P. At this point, the angle should be a right angle. This angle is 90 degrees. So how we do is, we'll take O as origin. Let OA be A vector. Then this is same in the opposite direction, no? So this will be minus A vector. Now take any point P on the semicircle with position vector as R. So that is OP is equal to R. So OA is equal to A. And then OB is equal to minus A. And then OP is equal to R. Now when you OA is the radius. When you take lengthwise, it is radius. This is also radius. This is also radius. So mod OA is same as mod OB is same as mod OP is equal to the radius of the circle. Radius of the circle. So when you take the complete circle, it becomes a radius. So all these are equal to radius. So OA is same as mod OA is same as mod OP. So this idea now we need. Now we must show that this angle, that means PB and PA, angle between PB and PA is 90 degrees. So what we do is, we'll find PB dot PA. PB dot PA. What is PB? OB minus OP. Dot PA. PA is OA minus OP. OA minus OP. Now OB means B. OB means minus E. So it is minus A dot minus OP is R. Minus A minus R dot A minus R. You must show that it is 0. So if you take minus of common, then it is A plus R dot A minus R. So it is minus of mod A square minus mod R square. So mod A is same as mod R, isn't it? Mod A is same as mod R. Mod A, these lengths are equal. So mod OA is A. So mod OA is equal to mod OP. So mod A is equal to mod R. So this becomes 0 because mod A is equal to mod R. So like this we prove. So angle at here is 90 degrees. So the angle in a semicircle is a right angle. So like this we prove all these theorems. Still we have one more. Now you understood the method. Now we'll write it in detail. So we discussed the proof. Now it is like this. By vector method, prove that the altitudes are concurrent. So you will take the altitudes AD and BE. Suppose that they intersect at O and O be the origin. So let OA is equal to A, OB is equal to B, OC is equal to C. And then OA is perpendicular to OA extended is perpendicular to BC. So OA dot BC is 0. So you'll get one equation like this. Similarly, this OB is perpendicular to AC. So their dot product is 0. You'll get like this. So from these two, A dot B is same as B dot A. So these two should be equal. So when you simplify, you get like this. So from these two, you can say that A minus B is nothing but BA vector. BA. OB, this is OA minus OB. OA minus OB means BA vector. BA and OC is C. So that their dot product is 0. So they are perpendicular. So the altitude CF. OC means OC extended line is CF. So CF is perpendicular to AB. So CF is also passing through O. So all the altitudes are concurrent at O. Hence it is proved. Now angle in a semicircle is a right angle. To prove that angle in a semicircle is a right angle, first we'll take the circle with center as O and radius A. So OA is A. OB will be, that diameter is AB. So OA is A, OB will be minus A because it is in the opposite direction. So we'll take that vector as minus A and take any point P on the semicircle. Take its position vector as R. Then these lengths OP, OB, OA are all equal. So their lengths are all equal. So now take PA dot PB. So that is A minus R dot product, A minus R dot A plus R, minus of A plus R. Take minus 1 outside, then it becomes like this. Then it is minus A square minus R square. So minus A square plus R square, that is 0 because these lengths are all equal. So because the dot product is 0, PA dot PB is 0. PA is perpendicular to PB. So when PA is perpendicular to PB, for any point P, you will get the same thing. So angle in a semicircle is a right angle. So like this we prove. Now there is one more theorem. I'll first explain. Still we have to write the theorem proving that the perpendicular bisectors of the sides of a triangle are concurrent. Now still I have to write that, and one more theorem is there. In a parallelogram, prove that the sum of the squares in a parallelogram, prove that the sum of the squares of the lengths of the diagonals, sum of the squares of the lengths of the diagonals, that means AC square plus BD square, AC square plus BD square is equal to the sum of the squares of the lengths of its sides. Sum of the squares of the lengths of its sides means AB square. So AB square plus BC square plus CD square plus DA square. So this is what we have to prove. So the method is, you will take AB as A and then BC as B. Then AD will also be B, and this DC in this direction is A. So you will get AC plus B. AC, what is AC? AC is A plus B. AC is A plus B. So this is A plus B whole square plus BD. BD is BC plus CD. So that is B minus A. CD means minus A. So it is B minus A whole square. So when you simplify, it is A square plus B square plus 2A dot B. And this is A square plus B square minus 2A dot B. So they will get cancelled. And you will get 2 times A square plus B square. 2 times A square plus B square can be written as A square plus B square plus B square. So one A square you will write as AB square. Another A square you write as DC square. This again as BC square. And this also again as AD square. So you will get it as the sum of the squares of 4 sides. This is another theorem. So these 2 theorems now I'll write. After that we'll take down the homework. So we discussed about the perpendicular bisectors of the sides of a triangle are concurrent. So the proof is like this. So in triangle ABC, let DEF be the midpoints. Take the midpoints of the sides as DE and F. And then take any 2 bisectors. They intersect at some point. Take that point as O and O be the origin. Now take the vertices OA, OB, OC as ABC. These are the vertices. Then D is the midpoint. No, so its position vector will be B plus C by 2. E will be A plus C by 2. You have learnt about the position vector of midpoint in addition of vectors chapter. So we wrote the midpoints, and then because the OD is perpendicular to BC, their dot product is 0. So B plus C by 2 dot. When you cross multiply, 2 will go. So it is B plus C dot C minus B. So C square minus B square is equal to 0 like this. So C square is equal to B square. In the same way, AC is perpendicular to OE. So their dot product is 0. So you get like this. So now from these 2, you will get A square is equal to B square is equal to C square. So instead of, now A square means OA square is equal to OB square is equal to OC square. So now take AB dot OF. Now you take AB dot OF. You will get this as 0 because B square is equal to A square. So they are perpendicular. So like this you prove. So the perpendicular bisectors of the sides of a triangle are concurrent. Now you can take down this homework. A, B are vectors. Find the projection vector of B on A. Projection vector of B on A is B dot A into A by mod A square. So find out that and then find its magnitude. So in the last period you have learned the formulae. So apply that. Next is vector component of B in the direction of A. The answer for this is this. And then vector component of B in the direction of A is B dot A into A by mod A. So you will get the same thing here. And then perpendicular to A. Vector component of B perpendicular to A is B perpendicular to A. Vector component of B perpendicular to A is B minus b dot a into a by mod a square. So that formula you apply. Perpendicular, the vector component of b perpendicular to a is b minus b dot a into a by mod a square. So when you simplify, you'll get that j minus k. So we already discussed this theorem. In any parallelogram, show that the sum of the squares of the diagonals, sum of the squares of the lengths of the diagonals is equal to the sum of the squares of the lengths of the sides. So you have taken the parallelogram OABC, take O as origin, or OA is equal to A. So OC is in any general property. To prove any general property, you can choose your origin conveniently. So one point if we take as origin, it is easy to simplify. So we'll take OA as A and this OC as B or C, because it is C. I took this as C. So OC is equal to C. Then OB is equal to OA plus AB. OA plus AB is A plus C. So similarly, the diagonal AC is AB plus BC, or you can take this way also. Anyway, you can take. So it is AB plus BC is AC. So according to that, it is C minus A. Now sum of the squares of the lengths of the diagonals. So that means it is OB square plus AC square. So you substituted the values, expand. You know that A square is A dot A. So take dot product, expand, then this will get cancelled. You will get like this. So write one side one A as OA square and then another A as CB square. So when you write like that, it becomes the sum of the squares of the lengths of the sides. So like this we prove this theorem. Now we'll do one more problem because we have time. We'll do one last problem, simple problem. So find the unit vector. Next problem, find the unit vector. Find the unit vector parallel to, find the unit vector parallel to XOY plane. XOY plane and perpendicular to the vector and perpendicular to the vector 4i minus 3j plus k. So you must find the unit vector parallel to xy plane. So any vector parallel to xy plane means it will contain only x and I and j terms only. K will not be there. So any vector, general vector, any vector parallel to xy plane, any vector parallel to xy plane is of the form xi plus yj. Is of the form xi plus yj. So now it is a unit vector. So we'll take this as some A is equal to some A we'll take. Now A is a unit vector. Suppose that it is some vector A. A is a unit vector. It is given that A is a unit vector. So that means what? Its modulus is 1. Its modulus is 1. So what is the modulus of this? Modulus of this is root of x square plus y square is equal to 1. So that means x square plus y square is equal to 1. By squaring you get like this. Now this vector is perpendicular to this vector. So that means A is perpendicular to 4i minus 3j plus k. This is given. This is given. So what happens? You'll get. So that when any two vectors are perpendicular, their dot product is 0. So A dot of 4i minus 3j plus k is equal to 0. But what is A? Xi plus yj. So xi plus yj dot of 4i minus 3j plus k. 4i minus 3j plus k is equal to 0. So when you take the dot product, it becomes 4x plus minus 3y is equal to 0. K is not there. So here it is 0k. 0k into 0 into 1 is 0. So 4x is equal to 3y. So that means 4x is equal to 3y. Now solve these two, 1 and 2. So from this we'll find out x value. What is x? X or y you can find out. So we'll find out x. So x is equal to 3 by 4 into y. So now substituting in 1 we get x square plus y square. So 3 by 4 y whole square plus y square is equal to 1. So that means 9y square by 16 plus y square is equal to 1. So when you take LCM, it is 9y square plus 16y square is equal to, by 16 is equal to 1. So that means 25y square is equal to 16. So y square is equal to 16 by 25. So y is equal to plus or minus 4 by 5. Y is equal to plus or minus 4 by 5. Now from this you find out x. So therefore when y is equal to 4 by 5, what is x? X is equal to 3 by 4y. So 3 by 4 into 4 by 5. So that is 3 by 5. Similarly, when y is equal to minus 4 by 5, you will get x as minus 3 by 5. So after finding x and y values, you substitute in the vector in this plane, in this vector, any vector parallel to this vector. In this you substitute. So therefore the required vector is, xi plus yj. Xi plus yj, that is equal to plus or minus, when I take x as 3 by 5, y is 4 by 5. When it is minus, both are minus. X, y both are minus or both are plus. So you will get the answer like this. So if you understood. So first take any vector parallel to xy plane as xi plus yj. Because it is parallel to xy plane, z won't be there. So xi plus yj. So take that as some a, because we should show that we need this equation because it is a unit vector. Mod a is 1. So you substitute, you will get like this. It is perpendicular. So dot product is 0. So you are getting two equations in x and y. Solve them. Here because you have squares, you find out x and substitute here, find out, and then your answer is xi plus yj. So substitute the values of x and y plus or minus. So like this we'll do the problem. Still we have one cube problem that is again very important, finding the angle in between the diagonals in a cube. After that we can discuss about the vector equations of the equations of planes, vector equations of the plane in terms of dot product. That we'll learn in the next period. Okay.